Assalamualaikum and hi. So today I would like to present about introduction of SCADA system. SCADA is a short form for supervisory control and data acquisition. SCADA system also acts as centralized platform where the operators can remotely monitor the system. There are two objectives of SCADA system. The first one is to ensure the SCADA system is hardly to access, and the second one to analyze the data trends where to optimize the process. SCADA system also is underlying monitoring and control the element of vital infrastructure including telecommunication, power and transportation. For configuration, SCADA advantage, my friends will explain about it.
What is a communication in power system? A communication in power system that made up a three component, which is a transmitter, receiver and communication channel. Varied communication channel and network topologies offer a very option to improve the speed, security, dependability and sensitivity for the protection relay. There are five types of communication media, which is a power line carrier, or we call it as a PLC, microwave, radio system, satellite system, and lastly is a fiber optic. Start with the PLC. It is suitable for the station communication, but it is a limited coverage and low bandwidth. Secondly, microwave is a signal receiver in a disc-shaped antenna, and commonly we can see at our residential like television. And thirdly is a radio. It is act as a transducer that convert the information to be a time varying and also known as a modulation signal. Next is a satellite, which is a transmission of data from one location to another communication satellite around the orbit of Earth. And lastly is a fiber optic, which is employ a light wave technology to convert an electrical signal into a light and transfer a big bandwidth data over an optical fiber. There is example of the fiber optic, which is SCADA and internet cable. We go for the SCADA architecture. Start with the intranet that made up of the internal to the company network, and it is easier to use by applying analytics to gather the data. From the intranet, it will divide for the two, which is the HMI and operator. HMI is easier for the SCADA system to communicate with the operator, and operator is an individual that keep an eye on the system, and they have access to the system either remotely or the company premise. From the operator, it will go for the MTU, which is receiving data from the remote terminal, sending control signal and relaying the data to the HMI. From the MTU, it will go for the RTU, which is provide the designated control signal to the field device, and it will communicate with the MTU. Lastly, from the RTU, it will go for the field device, which is spread throughout the company and made out of the industrial process control and monitoring equipment.
So this is a SCADA major component and function, which is the three types of component that we usually use. For the first one is the RTU or PLC, data acquisition and control system. So for RTU and PLC, it collects the data from the sensor and send the control commands to the actuator. For the data acquisition, the data that we retrieve from previously RTU and PLC, that data will be processed to provide information for future analysis. So this can allow the operator or the engineers to see the historical trend and the performance. For control system, this system will sending the commands to the actuator based on the input that we achieve. This can ensure that the industrial process operates within a specific parameters and can be adjusted to optimize the performance.
Next, we go for the SCADA communication and protocol. Communication protocol that has been developed to achieve a continuous, dependable, and effective communication between the SCADA component. There is two types of protocol, which is DC bus and MOD bus. DC bus is a line topologies, while the MOD bus is a line, star, and ring.
Next, the contribution of SCADA in power system. So we know that we use the real-time monitoring. It allows operators to have a comprehensive view of the power system status. It also helps in detection of fault or any potential issues. It also have a quick inventation and reduce the downtime. For fault detection and diagnosis, we can detect and diagnose the fault earlier. We have a quick response and corrective action. We also can preventing the escalation of issues and enhancing the reliability of the power grid. For load balancing and optimization, it helps us to optimize the use of the resources and equipment. It also can ensure the efficiency energy distribution and reduce the likelihood of overloading.
Hi, so back to me for the advantages and disadvantages of SCADA system. What are the advantages? SCADA system don't require a complex configuration. Moreover, SCADA system can be continuous monitoring or controlling at any remote location. So this is much more easier for the operator or any industrial. And last but not least, SCADA system can large reduction in the labor expenses because SCADA system can minimize the physical workers. But every advantages will have the disadvantages. Same goes to the SCADA system. SCADA system is susceptible to the virus or any other cyber attack. Moreover, SCADA system is hardly to maintain the data quality. And last but not least, SCADA system will require any skills or any maintenance skills for any challenging happen. So that's all for my part.
Hi, I will explain the real application of SCADA system, which is fault detections. First, identifying fault locations by delivering real-time and historical about the performance status of the system. Second, quick alarm and notification for usual and important conditions. 3. Diagnosing system issues by offering tools and methods for analyzing data. And lastly, perform fault diagnostic techniques like trend analysis. Next, I will explain SCADA applications with sensor. As we know, sensor can detect and communicate data regarding temperature, pressure, and flow. So here I will explain how sensor works in fault detections, steam boiler in power plants. Okay, here is 3 sensor. Sensor 1 as detect aggregations fault. Sensor 2 identifies scope of embrittlements, and sensor 3 detect high temperature of corrosions. This sensor transmits signal to fault detection systems, PLC. Then PLC internal logic program can detect these 3 types of faults. After fault detections, alarm 1 as for agglomeration fault, alarm 2 as for identify embrittlements, and alarm 3 for high temperature corrections will display on SCADA systems. Thank you.
Hi, I will now elaborate in detail on how SCADA system work for fault detection in power system distribution in terms of monitoring, logging, data acquisition, control, and display. The first one is monitoring. SCADA system monitor the power system by collecting data from sensor and imputing values. The data collected includes voltage, current, frequency, and other parameters. The data then transmitted to the SCADA system for processing and analysis. Next is logging. SCADA system log the data collected from the sensor and input values. The data is stored in a database for future reference and analysis. Next is data acquisition. SCADA system acquire data from programmable logic controllers (PLC) or remote terminal unit (RTUs). The PLCs and RTUs collect data from the sensors and input values and transmit the data to the SCADA system. Next one is the control. Control in SCADA system can automatically control isolated switches and circuit breakers for violating. In the event of any power outages, SCADA system can detect the exact location of the fault and alert the operators to identify and prevent it from happening. Lastly, in terms of display, SCADA system use human-machine interface (HMI) software that permits users to interact with machines to control the device. HMI is connected and many more devices. The SCADA software receives the information from PLCs or RTUs, which in turn receive their information from the sensor or outputted values that have given manually. Thank you very much.
So in the end, SCADA system can be used in a large scale of power systems such as the power grid. The system provides real-time monitoring and control, which is allow the operators to have a comprehensive view for the overall power grid. This allows for a quick detection of fault and faster response time to improve the system reliability. While for the PLC, it serves as a backbone of automation in our system. PLC contribute for optimization process such as the load balancing, voltage regulation, and the full isolation, which can improve the energy distribution and reduce the downtime. So, in conclusion, by using both SCADA and PLC in communication of our system, it can be represented as a paradigm shift towards to a more intelligent, efficient, and reliable energy infrastructure. This technology empowers the utilized to meet the demands of an increasingly dynamic energy landscape, ensuring the stable and sustainable power delivery to the communities around the world. That's all from our group. Thank you.